Welcome to Vertical City. I'm your host, Lennon Richardson. During each episode, I interview one of the world's top experts in architecture, urban design, engineering, or ecology so that we can better understand and develop solutions for sustainable living. Thank you for listening, and get ready to join us on another groundbreaking and uplifting episode. Stephen is the president at Stephen Turner Inc., a building commissioning company based in Providence, Rhode Island. He is an expert in engineering, construction, commissioning, operation and maintenance of buildings and building subsystems with over 35 years of experience in the industry. He is also an expert in building energy and sustainability and is LEED accredited. In this interview, we discuss the commissioning process as it relates to new and renovated projects and what special considerations must be made when dealing with very large structures. We also discuss the pros and cons of building big from energy and sustainability perspectives. Join the conversation today and let us know what you think. Is building big humanity's most sustainable approach? Visit verticalcity.org/podcast to comment and to access complete show notes regarding everything we discuss here today. Stephen, welcome to the Vertical City podcast.
Thank you, Lennon. It's great to be with you today.
Yes, I'm really interested in learning more about the commissioning process, and I think that's really a good place for us to start. For those of us who are less familiar with commissioning, can you give us an overview of what that process entails?
Sure. Building commissioning is a quality-oriented process, typically controlled by the owner or the developer of a new construction project in the most common form. And essentially, the commissioning process seeks to verify and document what the owner's requirements are for a construction project and ensure that those outcomes are realized at the end of the built project. So we really are the owner's quality process to help ensure that their requirements are met in the final built project. So that definition aligns closely with the industry standard, which is commonly used as the basis for the commissioning process in the United States, which is published by the American Society of Heating, Refrigeration, and Air Conditioning Engineers. And for many years, there were only informal guidelines available, but as the industry continues to mature, last year, the first standard in normative, kind of code or mandatory language was published. And in a broader sense, commissioning is a practice which has existed in the maritime world for centuries. You may have heard of sea trials, which a ship undergoes when it's first launched upon completion. And essentially, a shakedown cruise occurs where the vessel is exercised through its entire operating range and in real-world conditions to ensure that all of its systems are functioning properly and that it's ready to be put into use. And that's a very rigorous process, and it's one that I had the chance to participate in early in my career, and I can tell you more about that if there's time. But this concept of maritime or naval commissioning was moved over into the buildings world, and a burst of activity occurred with a couple of centers of gravity in the early 1990s. And the late Nancy Benner, who worked at Portland Energy Conservation Institute out on the West Coast, was one of those centers of gravity, and I had the good fortune to work with her in Florida when I was working for the state of Florida at that time. And the grandfather of commissioning is widely recognized as a gentleman named Chuck Dorgan, who's a fine engineer and a professor at University of Wisconsin for many years. and with whom I've had the opportunity to work very closely through the decades. And in fact, I'm an instructor for the University of Wisconsin in the commissioning courses that he founded and which continue on following his retirement. And both of these individuals helped to shape the modern building commissioning practice into what it is. And I think another important attribute of commissioning is that it's viewed as so essential for high-performance buildings to be commissioned that it is not possible to obtain any form of green building certification without commissioning the project. So whether it's a LEED plaque that you're trying to earn or any of the other green building certification approaches, the Collaborative for High Performance Schools or others, all of these green building programs require commissioning to be a part of the delivery process to help ensure the performance of building systems. So that's an overview of the commissioning process, and I'm happy to unpack any parts of that explanation if you have any follow-up questions.
Yeah, that is really interesting to me. I'm surprised to hear that the industry is so new as it relates to buildings. I know, as you mentioned, they've been commissioning ships for a long time, but I guess I had kind of assumed that this was something that was always taking place, but it sounds like you're saying that maybe something was happening other than commissioning prior. I mean, I'm assuming that any subsystem that goes into a building would have to be checked in one way or another. Can you give me an understanding of what it was like prior to sort of a formal commissioning?
That's a really insightful question, Lennon. So if you think back to the 19th century, you think about who was an architect and what was their role. The architect was really a master builder. So if you were building a building even into the late 1800s, there was an architect who was on site every day who was directing everything about it, whether it would be the bricklayer or the finish carpenters or the steam fitters or the furnace builders. And this master builder had this single concentrated responsibility for making sure that the entire facility was constructed and turned over to the owner and was working. And then through the 20th century, with specialization, the increasing complexity of buildings, and simply the larger scale of buildings, that concentration of sole responsibility in one person was diluted over time. So large, complex construction projects today will have design teams that range up to 50 or 70 people, a structural engineer, a geotechnical engineer, a vertical transportation specialist, a specialist for every aspect of the building that you can imagine. And it's beyond the grasp, not only the technical grasp, but the attention span of one individual to ensure the proper delivery of all of these systems. At the same time, each one of these sub-consultants or specialists has been under market pressure to lower their pricing to be competitive, and therefore, as pricing pressure takes its toll, each of these specialists has scaled back their involvement, and I think the net result has been that design teams no longer do as much construction administration and turnover effort as they once did. And so a vacuum developed in the industry. Just at the time when a building is being turned over to the owner and it needs the most attention from the people with the best understanding of the systems in it, all of those people are running out of fee, running out of attention span, and moving on to the next job. So owners started to have unpleasant experiences with building failures and system failures upon turnover, and in their frustration, they welcomed the idea of this commissioning process to fill the gap that had emerged in the modern buildings industry.
That's really interesting. So it seems like it was really in effect because designers and builders were separated. And so if I'm hearing you correctly, it sounds like the commissioner's job is to be more of a generalist and to have an understanding of all of these different systems. Is that correct?
I think that's a true statement, Len, and I think that the reintegration impact of commissioning is one of the most sought-after effects which motivate owners to embrace commissioning. Many of our clients are sophisticated owners of many buildings, and their first experience with commissioning, in some cases, does not predate the green buildings era, and they may have tried commissioning several times without enjoying the real benefits of a good commissioning process. But once they see what commissioning really can be, they drunk the Kool-Aid, and they typically embrace the idea of commissioning all of their work because the benefits of a well-turned-over, properly functioning, adequately tuned building are extremely valuable.
So as our buildings become more complex, there definitely is a need for these silos of expertise. But I've heard many people argue that because we've become so isolated, so many experts have such little awareness about other industries that they're not working together as a cohesive unit, and that there can be some negative effects of that. Do you see that happening at all as a commissioner? Are you seeing how some subsystems may negatively affect the performance of others?
We see this in traditional delivery methods. So in the industry, we talk about the traditional design, bid, build method, where you hire a design team to complete a set of documents which specify the construction. And then you put those out to bid, and you hire a contractor to build the building as specified and planned, and then it's turned over to the owner. We see a lot of that siloing in that approach. Commissioning is not the only tool available to today's owners to address this siloing that we're talking about. So sophisticated project delivery methods have emerged. One of the early trends was towards a different delivery method called design build and its close relation construction manager at risk, whereby modifying the traditional design, bid, build delivery method, owners sought to reintegrate these teams. And today we're working within some very exciting frameworks, including what's called integrated project delivery, where the owner, the contractor, and the designers all enter into mutual contracts with each other and partner to accomplish a project within a target budget range, and it results in some very real de-siloing, some very real integration, reintegration, and allows teams to access those synergies of interaction. But even on those projects, there's still this gap in the first year when the construction crews are done and all of the people who know the most about what's been built have shifted up the road and gone on to the next project. And we as the commissioning authority are still there with the owner, helping them get their arms around this new building and helping to tune and operate this building in a hopefully an optimal way. And so that's the exciting role for commissioning, even when it's used in combination with some of these other efforts to reintegrate the industry.
You mentioned the design build process, so I just want to make a comment for our listeners. I did a previous interview with Gluck Plus, and they're experts in the design build process. So if you're interested in that, you can check out that previous interview. So you've talked about a few different systems here, Stephen, that you're looking over when commissioning. Can you just kind of outline maybe a comprehensive or semi-comprehensive list of the systems that you would be analyzing, and then from there discuss which ones tend to have the most difficulties?
Certainly. Well, additionally, the commissioning industry in the United States has been largely driven, for many projects, by the green building certification ambitions of the owners. So if they decide, well, I want to have a LEED plaque on my building, They may not realize it at the time, but they have decided to commission their project. Why? Because one of the prerequisites for earning a LEED plaque is to do at least some level of commissioning on the project. And defined at that sort of entry level of commissioning, if you will, the systems that would be addressed would include all of the heating, ventilation, and air conditioning systems and their associated controls, the lighting systems and their controls, including daylighting controls such as motorized window shades, and domestic hot water, or hot water that comes out of the tap for use by occupants. Those taken together, of course, have the common thread of being directly related to energy use in the building. Taken at a broader view, some owners choose to commission many more systems than that. So we may get involved with sewage ejector pumps, with rainwater collection systems, with photovoltaic systems, with solar thermal systems, wind turbines, geothermal technology, all manner of systems which are complex, often somehow related to the sustainability of the project. And then some owners take it further. We are starting to perform building envelope commissioning regularly for our clients who have come to understand that the windows, the walls, the roof, indeed the water vapor retarder under the slab of a building are just as important to energy performance as the air conditioning system in the building. And so we are seeing a trend towards commissioning of more and more systems and subsystems in a building. And the end point of this is one that was envisioned by Chuck Dorgan, the grandfather of commissioning, who describes total building commissioning in terms that have no limits, where the commissioning effort encompasses the entire project and no aspect of the building would be left uncommissioned. But that is rarely implemented in the real world today.
Is commissioning moving towards a more encompassing scope, though?
In our practice, yes, but we're very fortunate because we focus on sectors that bring us to really blue-chip clients. So Ivy League colleges and universities, large sports arenas, municipalities who have adopted sustainability goals. We work for a limited slice of the building sector, which by nature of their mission or their orientation have a very high degree of inclination towards sustainability. But a lot of the commissioning industry is working in a more price competitive and fundamental services environment where they're unfortunately being selected on a price-only basis, not a value-added basis, and are forced to deliver services at the price point that it takes to win the job. And so there's sort of two countervailing trends in the industry. One is a select sector pushing towards higher value-added, more integrated commissioning, addressing a wider range of systems, and then another set of providers who are being forced to provide dwindling services for ever more competitive prices. And we're studious about avoiding that sector because of the risks to our reputation, and because we enjoy a very fine reputation in the one sector, we're not forced to dabble in the other.
Sounds nice. So, Stephen, as you're taking on larger scopes, how much of this is happening in-house, or are you acting as more of a general contractor and bringing in other experts to do the commissioning of certain subsystems?
That's a great question. A lot of firms do adopt that latter business model that you described, Lennon, and they will provide only core commissioning services with very focused expertise, perhaps heating, ventilation, and air conditioning systems, or HVAC, as we call it. and bringing in outside experts on engagements that require others, we have a very specific commitment to ensuring that we have a multi-dimensional team. Our team incorporates experts with deep knowledge of electrical systems and energy generating systems and electrical distribution systems. We have people with architectural backgrounds on the team who bring the requisite expertise for commissioning building envelopes. We have geothermal expertise in-house. We have expertise in testing, adjusting, and balancing air distribution and water distribution systems. We have really deep knowledge across a range of sectors. And after 7 years in business, we've reached a critical size of 15 team members, which allows a richness in-house, which is a real luxury in the commissioning field. Most firms are either a standalone firm that will reach outside the firm for those broader areas of expertise, or they're a small group affiliated with a large engineering firm often, and they'll reach across to the parent engineering firm and pull designers and others with the requisite expertise into the commissioning effort as required. We're firm believers in the value of having that deep expertise embedded directly in our team, and we're a very close-knit team, and we've worked together on projects large and small, everything from a single classroom renovation in an elementary school all the way up to an international soccer stadium in the Arab Gulf region of vast scale. You know, it's kind of a luxury that we enjoy either as a result of our hard work building the business. So you'll find both conditions exist out there in the industry, depending on what firm you're looking at. Mm-hmm. But we're one of the larger firms that are dedicated solely to commissioning, and as a result, we're able to integrate that expertise right here in-house.
Great. Can you share an example with me of a benefit that commissioning has given to a client where you've been able to discover a problem before it became a big problem and address it before the building was handed over to the owner?
Well, sure. I mean, that's one of the reasons that folks hire us and that we enjoy a good reputation. So it's kind of a fun question to answer. You know, there are some funny stories around this question, but before I share one of those funny stories with you, I'll give you the more serious answers. In the design phase of a project, we perform commissioning design reviews, and we try to identify, in particular, elements of the owner's project requirements, which we have identified through interviews or workshops or charrettes, and that we know the owner has an expectation around. And then if we find that it's not embedded in the design as the design team is moving forward in the planning and designing stages of the project, we try to highlight these so that the owner can make a decision and either confirm, yes, this is a requirement, we must have this in the design, or turn to us and say, oh, no, you misunderstood our requirements, we don't need it in the project, this is okay. So we have found projects where the lighting design relies on occupancy sensors in each room to turn the lights on and off, and the heating, ventilation, and air conditioning system relies on occupancy sensors to either maintain the room right at the temperature set point that occupants expect, or to allow that temperature to drift if it's unoccupied and save energy. So in design review, we have found cases where there are no occupancy sensors to accomplish either goal, and we found cases where there are 2 occupancy sensors in every room, one for the lighting system and one for the air conditioning system. And then, of course, we sometimes find a desirable result, which is 1 occupancy sensor or 1 set of occupancy sensors, if it's a large room, to control both the lighting and the air conditioning. And so there are lots of other aspects of design. Very often, especially in large systems, we'll incorporate a big machine like a chiller, for example, for an air conditioning chiller plant, which will be shipped with its own controls and its own sequences And we will find that as the project is being put together, nobody has any idea what those sequences are. And we'll be the first one to ask about it, because part of our work is to devise functional performance tests where we force a machine to go through all of its modes and safeties and alarms and failures and different seasonal modes. And so, of course, we need to know what those detailed operating sequences of control are. And when a set of controls is shipped as part of a larger piece of equipment, very often the manufacturer really doesn't want to tell the whole world what those sequences are. So one of the things that we do is press very hard for that information. And sometimes when it comes to light, engineers realize that the piece of equipment being used on the job is going to have to be substantially modified in order to fit with their vision of how it would operate in their particular building. This is kind of a symptom of a unique aspect of the buildings industry. We're not the automobile industry. We don't build 100,000 units of the same thing.
Right.
Every building is a one-off. So we can't afford to build the first 10 with some problems, get them squared away, and then build the next 90,000 correctly. We've got to figure out how to do each one right the first time, every time. And I think that's one of the core challenges in the buildings industry that has resulted in the existence of commissioning. In terms of actual operation, funny things happen. We worked a couple of years ago in an adaptive reuse of a historic mill building, and the canal running through the historic mill site was the source for the cooling water for the air conditioning system in this complex, the new modern system that was installed. And this system was not functioning properly. We were called in, and as part of the investigation, it was found that some very small eels had found their way in to some of the heat exchangers on the equipment, and they had been there for a long time, and they became very large eels.
Oh, my goodness.
And there was no longer any water flowing through these heat exchangers, and the entire system was malfunctioning as a result. So you never know what you're going to find out there, and we've seen some doozies.
That is really interesting. This is a funny story. Thanks for sharing that with me. So you also mentioned, I read some of your background, that you do recommissioning, or that you're basically commissioning new systems that are added to older buildings. Can you give me some understanding of what that might entail and how that would be different from commissioning a brand new building?
Yes. So we do a lot of graphical charting of our commissioning processes, and so in the audio medium, of course, I'm missing my visual props to explain this. So I'll try to convert these visual concepts into sonic concepts for the audience.
Appreciate that.
Before we jump into that, new building commissioning is unique to either new construction or very extensive, what we call gut renovation projects. And then when we go into an existing building which has been previously commissioned, whether it be long ago or more recently, we call that recommissioning. And logically, when we go into a building which has never been commissioned, we call that retro commissioning.
Okay.
And each one of those requires a slightly different approach. But in broad strokes, commissioning in new buildings has three major phases: the design phase, the construction phase, and the occupancy phase. And that's because the process is being followed by the commissioning team. But in an existing building, we have a 5-phase process, which is self-structured because we're typically working alone in these buildings, which is a significant difference. New building commissioning, we're working with design teams and contractor teams on work that they are currently doing. But in an existing building, there's no design team, and there may not be any contractors involved if the owner maintains the building themselves. So we're working much more on our own. And our 5-step process in an existing building is, in short form, plan, investigate, test, and recommend upgrades, then implement the upgrades, and turn over the modified building back to the owner and show them how to own and operate it from thence on. So that 5-step process is substantially different in an existing building as compared to the commissioning process in a new construction project where we're part of a delivery process which is ongoing. So hopefully that's understandable. I know it's a mouthful.
I think I got the gist of it, and if you have any links or anything you want to share, you can make a note of those, and I'll link to them in our comment section, which is verticalcity.org/podcast for any of the listeners who want to do some further investigation on their own.
Great. Our domain is buildingcommissioning.com, and that'll link you to some more information about this, and I'll provide that to you afterwards as well.
Great.
Just to follow up on that last answer, one of the differences is that if I'm testing a machine on a new construction project, I'm directing the contractors who installed it to how they will take the next step as we move through the test. I will actually not be swinging valves and changing settings and doing work. I'll be leading the test and directing the contractors, because at this point, typically, they still own all of these systems. Mm-hmm. So they are the ones performing the work. Whereas you can imagine in an existing building, our teams more typically are going in, and we ourselves are manipulating set points, opening and closing valves, doing things to get through the test steps and see how the equipment responds. So existing building commissioning is a much more lonely existence, and in some aspects may call for a higher degree of practical experience and hands-on expertise. And that's one of the characteristics of our team, that we integrate a core of youthful, very energetic, very intelligent team members with a core group of, shall we say, graybeard technical experts.
Okay.
Many of us have been in the industry for 30 or 40 years, and we've learned our lessons the hard way. So we know how to manipulate a large chiller without causing a failure in the large chiller, which would be a very expensive mistake to make. So existing building commissioning is sometimes a bit scary and hairy, but we like doing it, and we're good at it.
Yeah, it sounds like you have a really dynamic team. I want to take us back to the commissioning of new buildings here for a moment. And you've mentioned that you've worked on everything from classrooms to large stadiums. And I imagine that as you go up in scale, that it becomes more complex and that you often will have to analyze more systems. Can you just give us an understanding of how it does change when you're commissioning very large buildings or very large structures in general?
Oh, sure. Yeah. Well, this is in fact a very interesting complement to sustainability thinking. So to start with the complementary line of thought with respect to sustainability, if you think of a small dwelling, let's say, at that scale, you can use passive techniques to achieve a high degree of energy independence. You could build an earth-sheltered, well-shaded, hyper-insulated building which barely needed any energy to heat or cool or even daylight it, and just sift energy by virtue of its form. But our clients tend to build classroom buildings, high-rise laboratories, natatoriums, which are swim centers, dining facilities with large-scale institutional kitchens, engine testing laboratories, nanotechnology laboratories, every form of research that you can imagine. We do a lot of for college and universities. And at this scale, those passive techniques for energy conservation and energy efficiency are of limited use. You can no longer get 90% of the way to the energy finish line with simple passive techniques. So the larger the building, the larger scale the problems become, and the more high-tech the solutions become. So a trademark of an increase in scale in the high-performance buildings that we primarily work in is an increase in the complexity of the systems and an increase in the interdependence between the systems. So it leads to very interesting and complex analyses. For instance, we've just brought online one of a series of schools for a municipal client whose goal is to build net zero energy schools. And the most recently completed project has over 0.5 megawatt of solar power on the roof generating. So in the month of June, for example, they produced 3 times as much electricity as they bought from the utility. So these buildings are very exciting, but they're also quite daunting to think about. So a traditional approach to cooling down a school building in the morning before it's occupied is to start the cooling system an hour or two before the people come in and lower the temperature in the school. But what we realize at this school is that that's precisely the time of day when the solar panels are producing little or no electricity. So we're experimenting with strategies to pull down the school to an abnormally low temperature at 3 or 4 o'clock in the afternoon as the people are leaving, and when we have abundant solar availability, and therefore we're using on-site solar power to achieve this pull down, and then we're buttoning up the building and shutting everything off overnight and trying to keep it from drifting up too hot overnight. And then we simply turn the systems back on a minute or two before the people walk in the morning, and we've gotten to the same end result, but in one way we've done it in a carbon-intensive utility electricity-focused way, and in the preferred method, we're using that clean on-site energy. We're not buying any power from the utility to do it, and it just seems a smarter way to do it. So these large, complex buildings have these unexpected sort of interconnections between different systems that are really a lot of fun to think about.
Yeah, that is a really interesting interconnection that you brought up, and I'm glad that you did. I'm really interested in learning more about how the different subsystems work together. So, okay, I'm also glad that you brought up the concept of passive house and small scale, because I know that that's a very sustainable approach. But I'm also curious, what are your thoughts around economies of scale, and aren't there certain ways that you can actually become more sustainable by building large?
Well, I warn your listeners now. Take my response with a grain of salt, because I'm a bit of a gadfly when it comes to grid power. So I'm a great believer in standalone, off-the-grid buildings at any scale. And that's where I think our industry has yet to really realize the economies of scale available in very large buildings. Currently, very large buildings tend to be very large users of utility-provided grid power. But these large facilities are sometimes of a nature or are sited in such a way that very large on-site renewable energy installations are feasible. And these are just beginning to be explored and exploited to any kind of degree. So I foresee a future where instead of simply accepting the limitations of a horizontal solar array up on a roof, where the roof size defines the maximum size of the array, I firmly believe that if you come back and look at buildings in a couple of decades, you'll see, for example, vertical solar arrays.
Sure.
MIT is doing some very exciting research on the potential for taking conventional solar panels and instead of just laying them out in angled arrays on a roof, mounting them in various orientations on vertical platforms. And so I think that some of the limitations which people look to explain their limited ability to reach net zero today, I think some of these limitations are going to be exploded as new and more exciting thinking is applied to some of these challenges. And I really think that we've only begun to apply our imaginations to these problems. And until we've really wrung out, at least gotten to the 80-20 rule, where I think we're maybe at 20-80 right now.
Okay.
We've got a long way to go before we say we're attaining the economies of scale available. There's very exciting technologies out there. We completed a swimming pool for a large university client a couple of years ago. Very exciting solar install called hybrid solar, where every photovoltaic panel is backed with a solar thermal panel. So there's water circulating in a panel behind the photovoltaics. And the heat that's gathered in the solar thermal panels is used to heat the pool. But what we learned on that project was that the solar panels generating electricity were kept cool by the solar thermal behind them.
Wow.
And the electric output that's coming from the photovoltaic panels is off the charts compared to the photovoltaic production from conventional solar installs that we've commissioned. And we've gotten very excited about a future where you're integrating solar thermal with solar PV. And certainly buildings are only starting to scratch the surface in terms of creative application of solar surfaces. I mean, in today's world, it's possible to spray apply photovoltaic film to any surface and use it to harvest electricity from the sun. But you don't see a lot of that in real-world applications. But we don't even know what the thinking is about wind and solar. I mean, just think, what about nanotechnology? What if we could have a roof shingle that was generating wind power when there was wind and sun power when there was sun? And I mean, what's coming is so exciting. That's why I'm so delighted to be in this business, because every project that we do, we're lucky to work on leading-edge projects, and each one just scratches the surface, and we look at that scratch and we say, oh my gosh, if somebody really dives down into this, there is so much potential here. So economies of scale that are achieved are sometimes in today's world related to on-site cogeneration or trigeneration, so that a small building may not be able to afford to put in a power plant that produces heat and chilled water and electricity, but a larger building may be able to avail themselves of that. So there's, that's a whole nother direction in terms of economies of scale. Another example are large floor plates with water source heat pumps, where we actually move heat from hot areas of the building, and instead of rejecting that heat outside of the building, we simply move it to another area of the building where we need it. So we can use, for instance, large slabs that have piping embedded in both the top and the bottom of them, which we call thermal active or active slab. And we can take heat from an interior zone where there might be a computer room, and we can pump it out to the exterior room that has windows. And in wintertime, instead of making new heat to heat that exterior room, we can just move heat from the interior room to the exterior room. And that's something that's difficult to do in a small-scale building, but is practical to do at a larger scale. And certainly in many of the projects that we work on, instead of just having a chiller which rejects heat outside the building and a boiler which makes heat in the building, the designers are able to implement systems which harvest the waste heat and reapply it within the building, kind of closing the loop on the thermodynamic side of the building. So those are just a few examples of economies of scale.
Yeah, those are really great examples. Thank you for sharing those with me and our listeners. So it sounds like that at this moment, small is still more sustainable, but in the future, do you predict predict that building big will be our most sustainable approach?
Well, let's be careful what we say here. We are on a podcast called Vertical Cities, so...
Well, you can certainly put forth different ideas. I mean, we're open here.
No, I'm partially jesting. But when I say that small-scale sustainability is apparently more readily achieved, that's ignoring all of the effects of land use. And, we're not aggregating these. Not everybody in the world can live in a earth-sheltered single-story hut and still have room for everybody else on the planet. So when we talk about overall sustainability and hopefully someday taking very large buildings beyond sustainability into the regenerative range, which is what I'm really interested in, buildings that have greater positive impact on the local ecosystems and negative impacts. I think that's really where large buildings come into their own, because essentially we can view these large buildings as opportunities to, again, to use the phrase, to close the loop. So whether it's Masdar or the sustainable city, and really the only loop that they haven't been able to close is the desalination plant. What do we do with all this salt? But I think at large scale, we get a much better opportunity to look at the loops and look at the boundaries and stop the flow of materials and energy across those boundaries, close those loops. The bigger the building, the more diverse use, the more likelihood there is that somebody somewhere else within our boundary will want something that we were going to throw away in some other part of the building. So from a pure logic perspective, I'm a believer in the economies of scale with respect to sustainability, and I'm also a realist, looking at the planet, carrying capacity, the population burden. If we're not talking about large scale, we're not talking about real solutions.
Yeah, I think that you've made a lot of comments that I personally agree with, and the land use one is a big one for me personally. But I also would make the note that there's not going to be one solution, and that every situation is going to require a different solution. We have just a few minutes left here, so I'm curious if you have any last remarks, an interesting project you want to talk about, or even a call to action that you'd like to make to our listeners before we bid farewell.
Well, that's if you have a few days, I can issue all my calls to action that are backlogged here in my agenda. A wonderful challenge. We here at our firm try to conduct our business in a small and respectful way. So we're a triple bottom line firm. We are not just looking at QuickBooks every month to see how much money we're making. We're trying to engage with the communities that we're active in. We're setting aside a fixed 1% of gross revenue on profitable projects every year goes to community-based nonprofits locally. We support and encourage our team members in engaging with pro bono activities and positive activities within the economy. We like to think that by organizing ourselves in a particular way and conducting ourselves in a particular way, that we're giving back as much as we're enjoying as we coexist with the communities around us. And at the end of the day, I don't care about whether you're in the commissioning business or any other business. I think that the ability to organize ourselves in that way and respecting the need to conduct ourselves in that way is one of the great privileges that life has afforded me. And I'm so grateful that I get to come to work every day and work in an environment where I feel that I'm not a taker. I'm part of a team which is giving and receiving and engaging with. And that is such a refreshing way to work and live. and really was something that when I started my career, I don't think it was available to me. There were really stark choices to make when I left college and started in the trades. I came up through the trades. So working as a tradesman many decades ago, there was really a dichotomy. You could tune in and drop out. You could join the Peace Corps, or you could work a straight job and work for the man.
Sure.
And there really wasn't a lot of choice. And I think that's just one of the great privileges of having a long career is living to see the day where we can create these little ecosystems which engage with and are sustainable in a multifaceted way, not just a zero carbon or an environmental footprint, but in a humanistic way as well. So that's my call to action: is enjoy the luxuries that living in today's world affords us. We can all make choices and spend our days in ways that give as much as we receive. And if we can all do that, dang, the world will be a better place.
Well, I definitely support those statements 100%. I thank you so much for making that call to action. And also, I just want to make a remark that I think that the reason that people have more options is because of people like you who were growing up and thought, I want to make money and I want to be a part of society and I want to contribute and have a job, but I also want to live by my ideals. And so I think, as you put it, the graybeards, as some of the graybeards grew up and became presidents of companies, that they've made that possible. And I feel very fortunate that that's possible for me and my generation at this time.
Cool. I want to thank you so much, and what a pleasure being on the podcast today. And I'm really looking forward to hearing more about the exciting work that's going on at Vertical Cities, and I know you're going to go on to great successes. And, of course, I'd be delighted to engage in any dialogue with or respond to any questions from listeners. So I'll let you take care of the logistics on that side, but want to reassure you and the listeners, delighted to engage directly in dialogue.
Great. Thank you so much for that. Stephen, give us your web address one more time.
You can find us at buildingcommissioning.com. That's www.buildingcommissioning.com.
And for our listeners, if you would like to engage in a conversation with Stephen and I and anybody else who's listening, visit our website, which is verticalcity.org/podcast. And you can remark on anything that you've heard here today, or you can answer a question that's on my mind: is what do you think the future of sustainability will be for humanity? Is it going to be building big, or is it going to be something else? Stephen, thanks again for your time. I really appreciate it. And I hope that you enjoy the rest of your day.
Thank you, Lennon. You too.
Thank you for listening to this episode of Vertical City. Learn more about the Vertical City concept and continue the conversation by visiting our website, verticalcity.org. I truly hope that you have enjoyed this episode. If you did, please subscribe to our podcast, leave a review on iTunes, and most importantly, share Vertical City with your friends and colleagues so that together we can create solutions for sustainable living. I'm Lennon Richardson, signing off for the Vertical City team. See you next time.